All right. Hi, everybody. Welcome to our webinar, Net Zero Strategies for Airport Terminals. My name is Simon Fowell. I'm an environmental economist based in Oakland for Autocase, a sustainability ROI software. I'm joined by three other amazing speakers here. We've got Tami McCrossen-Orr, who is Chief of Airport Planning at Los Angeles World Airports. And she's going to be speaking to us about some of LAWA's sustainability initiatives, their goals, and some key projects that they've got going on now and into the future. We've also got Richard Spencer, Aviation Design Director at Woods Bagot, based in their SF office. And he's going to dive deeper into the specific project that we're going to be talking about today, focusing on the key constraints and the design opportunities, sustainability, including things like modularity and circularity. And then we also have Heidi Creighton, who is the Associate Principal of Sustainability at Buro Happold in their LA office. And she's going to be outlining the key sustainability strategies that were done on this project around water, embodied carbon in materials, energy efficiency, bioflex design. And then I'm going to wrap it up by quantifying and valuing the broader social, environmental, and financial impacts of those various strategies. So with that, I'm going to pass it over to Tami to lead us off here.
Thank you, Simon, for that very nice introduction. So today I'm going to talk a little bit about LAWA, our sustainability goals. But first, I want to, for those of you who don't really know what LAWA is, you might not know LAWA. I want to just give you a little bit of background on LAWA itself as an organization. Next slide. So this is a map of LAX. LAX, I'm sure you all know, is Los Angeles International Airport. LAWA is a proprietary department of the city of Los Angeles, and we own and operate both LAX and Van Nuys General Aviation Airport. LAX is one of the largest airports in the world. In 2019, we were the fourth busiest airport in the world. We're the second busiest airport in the United States in terms of commercial passenger volumes. In 2019, so pre-COVID, we served more than 88.1 million passengers. We handled 2.3 metric tons of 2.3 million tons of cargo at our airport. So not only are we one of the busiest commercial passenger airports, we're one of the busiest cargo airports in the world. We rank 13th in the world for cargo tonnage process and 5th in the United States. What is really unique about LAX itself is that we operate on a very relatively small physical footprint for such a large airport. We are about 3,800 acres, and that's up from just a couple of years ago from 2,600 acres. We've acquired quite a lot of property to the east of the airport for airport expansion. Just to put this in context, so if LAWA was 3,800 acres, other large airports, like let's take Denver International Airport, Denver is 16,000 acres. So we are operating in a very compact physical footprint for so many passengers. So Denver has 16,000 acres. They serve 69 million passengers. So we're really looking at an airport that needs to operate efficiently. It needs to operate creatively to make sure that we can continue to move the number of passengers and the cargo that moves through our airport. Van Nuys is a general aviation airport. It's also located in the city of Los Angeles. It's one of the largest general aviation airports in the world as well. So we're the city department, LAWA, we operate both of these airports. They're very different operations. We've operated these airports for a very long time. But what's similar about them is that we operate in a tightly, densely packed urban area. I think that also makes what we're going to talk about today very important. Sustainability is important not just for the airport, it's important to the community. So next slide. So LAWA has been doing sustainability for a number of years. In 2019, our Board of Airport Commissioners adopted an updated sustainability action plan. But LAWA has been doing sustainability really starting in the 1990s. We were a leader in clean fleets and alternative fuels back in the 90s. And since then, LAWA's just continued to push the envelope on sustainability. We developed sustainability guidelines for design and construction more than 10 years ago. We were one of the very first airports to do that kind of work and give that kind of guidance to our development plan. So our new sustainability action plan, we're very excited about this, really focuses our sustainability efforts on energy conservation, air quality, water conservation, and waste reduction, kind of the really environmental areas. Doesn't mean that we ignore the other areas, but we know that these 4 areas are so critical to our being able to operate efficiently and effectively. Our SAP sets out bold new metrics and targets in each of these resource areas. We're aligned with the Mayor Garcetti, the Mayor of Los Angeles, Green New Deal for LA. And you can download a copy of our sustainability plan and a lot in our annual reports at laxsustainability.com. So our board, we really have evolved from a sustainability plan that was based on programs and just doing things, but we weren't necessarily working towards bold goals and targets. We just were doing things. And so this new sustainability plan sets bold goals for LAWA, where we intend to achieve zero carbon electricity for LAX and Van Nuys by 2045. We want to operate using with zero potable water for non-potable uses. So that's things like landscaping and industrial uses of water. That's also by 2045. We're right in the middle of developing a roadmap to become a zero waste facility, and that report and that plan is due by the end of this year. And really our, the overarching goal is for LAWA to be carbon neutral in our operations by 2045. The 2045 date is 5 years ahead of Mayor Garcetti's plans for the city of LA. So we're not just going to sit by and wait for other departments, other people to solve our problems. We're proactively solving our problems and reaching for our net zero goals. Next slide. So some of the, in the SAP, not only do we set these, long-term bold goals, we know that we need to have interim milestones and targets to make sure that we stay on track and to really guide how we're going to get there. So not only do we want to have 100% renewable electricity by 2045, we know that we need to increase our use of renewables. We need to increase the energy efficiency of our facilities. So we have interim goals in those areas. In the water, and it's the same thing for water. We have interim goals to increase our use of reclaimed water and to increase the efficiency of our facilities before 2045. We've already been, even though our sustainability plan was adopted last year, we've been working towards this for quite a long time. We've seen a continuous reduction in energy use per passenger since 2011. On a per passenger basis, LAWA has been able to reduce energy use 42%. Since 2011. We already have a large network of EV chargers at LAX with so many more to come in the development of our new facilities. Van Nuys, is a great laboratory, I'd say, for projects at LAX, just because of its smaller size and just smaller, we're able to do more things at Van Nuys. Van Nuys is really ahead of the game on renewable energy. Within the last couple of years, one of our tenants has installed a 1.5 megawatt solar power installation, and their plans for about 24 more megawatts at Van Nuys on the facilities there. So we're very excited about the prospects for energy, renewable energy at Van Nuys, and sort of leading the way for what we can do at LAX. So next slide. Thanks. You know, as I said, energy and water are very important, but truly one of the most important things at LAX is air quality. Air quality, as I said, we started our sustainability program really as a reaction to the air quality issues in the city of Los Angeles and in this region. And we started with our fleets and cleaning up our fleets. So we have a number of air quality improvement programs, and the sustainability plan really brings all of those together and, under the singular goal to reach carbon neutrality by 2045. Some of our interim commitments, we plan to have a 100% zero emission bus fleet by 2030. But we've already started. This isn't a far off goal for us. LAWA has already started. We received 20 60-foot articulating zero emission buses just last year. So those 20 buses operate on our airfield. So if you ever have the pleasure of flying into LAX and needing to take a bus, you'll be in one of our zero emission buses. You might think, how many buses does an airport have? LAWA's got a fleet of over 100 buses. Those are just our buses. So you can imagine how many other buses also operate at the airport, but we're committed to cleaning up our buses. One of our programs also recognizing that it's not just our operations at LAX. We're a facility that attracts so many stakeholders, so many third-party operators. One of our most successful programs is our alternative fuel vehicle requirement. And that program's been in place since 2007. And we're continually updating that program to move with technology. Right now, we require third-party operators of medium and heavy-duty vehicles that they must use clean vehicles at our airport. Their vehicles cannot be older than 13 years. We're really focused, so the vehicles are there's a lot of natural gas vehicles, but also we're seeing an expanding fleet of zero emission vehicles. And recognizing that is where LAWA wants to go, our board about 2 years ago adopted an incentive program to encourage operators to transition to zero emission buses. So our LAWA is putting $500,000 of its own money to help third parties convert their fleets. That's just a huge commitment, especially in these tough fiscal times. We have a similar program aimed at our ground support equipment. GSE is those really heavy, typically heavy duty vehicles and equipment that service the aircraft. So we're talking about belt loaders and bag tugs and catering trucks. And we've had a program in place since 2015 to help our operators reduce emissions from their GSE fleets. We've seen a 45% reduction in GSE emissions since that time. Our board has updated the policy just last year, recognizing that we can do more and that our operators can do more. Those are just a couple of our air quality programs. You can see there's some more listed here on the slides. But we also waste and material resources management is a huge focus for LAWA. Just this year, we adopted a food donation policy. So for our concessionaires and really any businesses who serve food at the airport will be required to participate in a food donation program. We've had a voluntary program for a number of years and it's been very successful. So we're really excited about the expansion and the rollout of this program to all of our concessionaires. It's just that kind of program is it's a win for everybody and especially for the community. Kind of what goes hand in hand with our food donation program is our organic waste recycling program. Under our sustainability plan, we'll be expanding. We have a pilot organic waste recycling program now that's been very successful, and we'll be expanding that to the rest of the airport concessionaires under the SAP. So those are just a couple of our initiatives and our achievements in air quality and material resources. But I think what we really want to talk about today, next slide, thanks, is really part of our LAWA's development and modernization program. LAWA's been aggressively modernizing its facilities starting really in 2004 with our master plan. The project that we're going to be focusing on today is actually part of the master plan. It's one of the last projects in the master plan, and that's the Midfield satellite concourse. But one of the key programs in our modernization is the Landside Access Modernization Program. This, under the LAMP program, it consists of really four main elements, the cornerstone of which is the automated people mover, which will be a 2.5 mile all electric zero emission above ground train that will transport people from our facilities that are outside the airport all the way into the central terminal area where passengers and guests can make connections to get on their flight. So this APM will finally connect LAX to the regional metro system. You can see that on this slide, right next to the ITF East will be a station that connects to Metro's Crenshaw line. Yep, right there, Simon. The other main elements of the LAMP program, starting out to the east, is the Consolidated Rental Car Center. This is going to be a 6.4 million square foot facility. There'll be 18,000 stalls for car rentals, and we'll have a direct connection to the APM, and it will be it's also adjacent to one of the largest freeways in the city of Los Angeles, the 405 freeway. So this will be a very efficient way for people renting cars to get them and get out of the airport, truly. This facility has been designed to be to achieve at least LEED Silver certification, and we'll have 4.7 megawatt solar system on that roof. That solar system will be able to power a large part of the Conrack facility, and in addition to the renewable energy features, the facility will also facilitate use of reclaimed water for the car wash. And of course, that water, the reclaimed water, will also be recycled and used over again. The facility will use 100% recycled water for landscape irrigation, and will be very energy efficient. The intermodal transportation facilities, those are sort of the next big elements in the LAMP program. The ITF West is being constructed right now. It will be a 1.7 million square foot facility. It'll have 4,300 parking spaces, and it will also be LEED Silver certified. The facility will have 30% of those spaces will have infrastructure for EV chargers, and also a large number of those will actually have the chargers already. The facility, the ITFs, will also be equipped with smart parking features, and so we're very excited about that. The train will also have a maintenance facility. This maintenance facility will be LEED Gold certified, and the maintenance facility will have 1 megawatt of solar power on the roof there. And that energy will be used in the maintenance facility and can also be used to power the train. So you can see, you know, the LAMP program was truly decades in the making, but we've embedded, you know, the sustainability features that, you know, the best sustainability features that we could at the time of planning these programs. All of these elements are in construction right now. The automated people mover, if you go to LAX, you will see the guideway being built in the middle of the central terminal area. The ITF West will open in 2021. The CONRAC will open shortly thereafter. So these facilities are in the works right now. This is really a key part of modernizing LAX. But there's so many more parts of LAX modernization, so many terminal projects, runway improvements. But I want to talk to you about one of those projects. And this would be the Midfield Satellite Concourse North. So this project, we're calling it the Midfield Satellite Concourse. This is a facility that will be in the middle of the airfield. It won't have a direct connection to any roadways. Passengers will access the facility via an underground tunnel that's connected to the Tom Bradley International Terminal. There'll be 12 to 15 gates in this terminal, and it's scheduled to be finished this year. The facility will be LEED Silver certified. It's anticipated that the energy efficiency improvements designed into this facility will save LAWA over 28% in energy costs. Their cool roofing and paving are being used to reduce the heating. And one of the really great features of this project will be, it will not only be piped to be able to accept recycled water, but LAWA has a project going on right now that will actually bring this recycled water to the Midfield Satellite Concourse. That project is a partnership with our LA Sanitation and our Los Angeles Department of Water and Power. This water is going to come up from the west side of the airport, from the Hyperion Water Reclamation Facility, which is actually kind of across the street from the airport. I'm sure you might not have ever noticed, but if you look to the south, west of LAX, there's where Hyperion is. That's where we'll be getting our reclaimed water. The water will come up from the west. It will go through and serve the Midfield Satellite Concourse, and we'll deliver that water all the way to the terminals and our central utility plant in the central terminal area, the center of LAX. That's a reality, and you know, we're very excited that the MSC and that LAWA has thought to design these facilities to be able to accept and use recycled water when it's available. And that day is truly coming soon. Another great achievement of this project is the high percentage of recycling and reuse of our construction and demolition debris. This project achieved over 90% construction and demolition debris recycling. And one of the ways that we did this was we have an on-site rock crusher. And so we were able to crush and use all of that recycling, the construction and demolition debris back at this facility. And not only is that great for recycling, that's also an incredible air quality improvement measure. We avoided countless truck trips just by locating the rock crusher on site and reusing those materials. It's a huge achievement. It's kind of not that exciting, but it's really important to LAWA on all of our projects that we recycle and reuse that construction and demolition debris. So this project is the Msc North Project. That project, as I said, is going to be completed this year. But I think our other speakers are going to talk about the design of the Msc South project. And I think that's where you can really see the evolution of sustainability at LAWA. You know, as we continue to build, we continue to seek more and more sustainable facilities, you know, as things improve, LAWA, we want to see those in our facilities. So I just want to thank you. This is sort of a rendering of what LAX is going to look like, and it's not that far off in the future. So a lot of exciting things happening. Thank you.
Thank you, Heidi. Well, this is Richard Spencer. Global Overshoot Day. This year was on the 22nd of August. Last year it was on the 29th of July. That's the day when we've used up 1 year's worth of resources that the Earth can provide as a global community. Thinking about this is this caused me to really question what I've been doing for the last 25 years, which has been designing and planning airport projects. I am convinced, however, that international travel is vital to our global community. It's just that we need to do it in the most sustainable way possible. So I'm going to discuss the Msc South project that Heidi has just mentioned. If we go to the next slide. LAX, Heidi has talked described it in considerable detail, but I think I need to show you exactly where the relevant project is. So if you could click on, we're going to be looking at this area just to the west of the central terminal area. Right in the middle of the screen is the Tom Bradley International Terminal. If we go to the next slide, we'll see both that, and to its left and the west is the Midfield satellite Concourse. So named because it is an island in the middle of the airfield, connected by a tunnel to Tom Bradley. And the area highlighted at the bottom of the picture is the site for Msc South. You'll notice the fluted roof of the large maintenance hangar that exists just there to the west of the Msc South site. That's the reason why the main building could not be extended fully down to the taxiways at the south. It does, however, give us the opportunity to do something that is sorely needed at the airport. Msc North is a fully featured international concourse with three passenger levels, basement with baggage systems, full arrival facilities, airline lounges. But LAX has had a shortage of narrow body gates for smaller aircraft and regional flights. And this site gives us the opportunity to create a very cost-effective facility that can piggyback effectively on the facilities built into Msc North. Because we can create those facilities with a much smaller amount of accommodation, if we go to the next slide, we can be very efficient and use the minimum amount of building to provide the maximum amount of passenger infrastructure. However, this site will be an island effectively in the middle of an active airfield once Msc North has been finished. And that creates significant issues for construction. All materials and all workers to work on the site have to come through security and be bussed across to the site and back again, which is ultimately very inefficient. So the options for doing off-site construction are very attractive. Secondly, the long-term life of the maintenance hangar is uncertain. So it could be that within the medium term, say 10 to 15 years, if that hangar is no longer required, the best use of the site might be different from that which we're proposing at the moment. And consequently, there's a real case for looking at how what we build on this site could be reused or adapted at that point in time, thus achieving circularity and making the best use of the amount of carbon that's actually embedded in construction. So, going to the next slide, when we began to work on the design of this project, we looked at both the possibilities for off-site construction and modularity, as well as looking at the standard planning characteristics of the building. And we're fortunate in that we're dealing with a single size of aircraft in this building, which lends itself very neatly to a modular construction where the wingspan of the aircraft and the sections of building that provide gate areas for those gates, seating and passenger facilities, match each other in terms of the module size. So we were able to establish a very good plan which would suit modular options. Next. We conducted a fairly detailed industry outreach to establish what was feasible within the context of building at LAX. There's a lot of application at the moment for modular construction, but it's mostly in housing and hotels, that sort of thing, where the unit size suits modules that can be built in a factory and brought by truck to site. The spans of an airport building are much larger than that. However, we do have the opportunity of creating some kind of construction site on the edge of the airfield and using large vehicles to truck pieces of building across the airfield at night for the site. There are about 5 different options in terms of the scale of modularity, and the one that was most appropriate for MSC South was the second one in that list, looking at large single-story modules that could be brought on oversized vehicles to the site and assembled, rather than either very large pieces or building out of individual components. The nature of the planning meant that we have 2 fundamental volumes to deal with: the large passenger spaces at concourse level, and then service modules connecting these with the services and the connections to the boarding bridges. Going to the next slide. This illustrates a construction sequence showing these elements that have been assembled on the site at the edge of the airfield, brought across on multi-wheeled vehicles and assembled on site. And subsequently, on the right, the idea that potentially we could move large pieces of this assembled building to either rearrange them within the site, as and when that hangar has gone away, or alternatively take them to some other part of the airfield for reuse. Apparently, these multi-wheel vehicles use AI to act as a swarm or a flock in moving things together, which is quite fascinating. So the final planning concept also has to address a number of other sustainability issues, such as controlling solar gain and glare from the east and west facades, because it's a north-south orientated building, as well as the opportunity to use solar panels on the roof. We did a solar panel check. Heidi will be telling you about that. But also we look to maximize the use of timber within the construction, again, to reduce the amount of embodied carbon. Heidi will now cover in more detail some of the specifics of the sustainability program that we adopted. Thank you.
Thank you, Tami and Richard, for those overviews. LAWA is doing such incredible work, so it's exciting to be here with you today, and thanks for joining us. So just wanted to start off with a little bit of context. As you know, just in the last few weeks, we've had 4.6 million acres in the Western US that's burned. And probably as many of you experienced too, over Labor Day weekend, we had record high temperatures across Southern California and the Central California region as well. And now tens of millions of us are suffering from the worst air quality that we've had in years, and that's from heat-triggered smog and from the fire smoke. And on top of that, this is threatening all of our lungs during a deadly pandemic. So we're really being pushed to extremes in our new abnormal. And the record heat, the fires, and the pollution all have one thing in common, and that's that they're being made worse by climate change. It's here today, and we really can't ignore it any longer. So our collective work really can't be on the left side of this graphic anymore, that are only meeting bare minimum code requirements and depleting resources, right? Each and every one of us needs to be on the right side, right? We need to be making a commitment to make advocacy a priority and to make every project as sustainable, as equitable, as healthy and resilient and regenerative as possible. So I know I'm preaching to the choir, so let's go ahead and dive into the first topic for this project. So over the next few slides, I'm going to be just walking you through some of the analysis and the outcomes of our work to date on MSC South. And as a requirement for the LEED integrated design process, we did a full water budget analysis, and that analysis calculates the anticipated volumes of water demand for the project. It evaluates the efficiency opportunities. It calculates volumes of potential non-potable supplies. It also explores water reuse opportunities available to the project. So this figure is showing the calculated water demands expected at MSC South. And there's no showers on this project, so the potable water demands will primarily be from lavatory and drinking water use. And the flushing demands will be water closets and urinals. And then the extent of irrigation is uncertain at this stage. You might have noticed some green areas in matured plans, but we will include any associated landscaping within the project in this, and we've used some conservative estimates for this calculation. So next slide, Simon. So in our water budget, the non-potable water supplies analyzed consist of gray water, rainwater, air handling unit, condensate capture, and then lastly, the municipal reclaimed water that Tami was talking about from Hyperion. So the water budget analysis for this project is relatively simple compared to typical projects, primarily due to the programming and to the extensive water conservation efforts that Tami outlined. So the planned Hyperion purple pipeline is a fantastic solution for this project. And after analyzing all the other reuse opportunities, we really only recommend moving forward with that reclaimed water. And that's going to result in achieving all 11 LEED water efficiency points through the following strategies. So 100% of the flushing demand will be served with the reclaimed water, and that will give the building indoor potable water use an 80% saving. We're also going to target cooling tower makeup offsets of at least 20% of the demand. And then finally, for all the landscaping that will be in this project, the irrigation demands will also be met with that reclaimed water. So now we'll get into energy. And as with any project with high sustainability goals, the process is really key. So first, we want to begin with passive strategies to minimize solar heat gain and maximize daylight penetration through the planning, the massing, and the detailing. And then we move into active and efficient systems designs. In this case, all electric systems for the terminal building. And then we look to offset the majority of the energy use with on-site renewable energy. And for MSC South, that will be the rooftop photovoltaic array. And LAWA has asked the design team to evaluate the feasibility of achieving net zero energy certification through ILFI for the project. And their definition for net zero energy is it's achieved when 100% of the building's energy needs are met on a net annual basis and supplied by on-site renewable sources. And no combustion is allowed, and certification is based on actual, not on model performance. Okay, next slide. So at this stage of the project, massing and orientation were pretty set and defined. So therefore, the recommendations that we're showing here are limited to the enclosure properties and to operations. So we studied various energy efficiency measures, and they were tested to determine which ones have the greatest impact on the overall energy reduction for the project. And so this table on the left shows the impactful measures and the associated energy savings. And the graphic on the right shows the energy reduction per EEM. And the longer that bar is, the more energy is saved by the measure. So we're recommending that LAWA adopt as many of these energy efficiency measures as feasible to achieve maximum energy reductions. I do want to make a note, though, that when these EEMs are applied cumulatively, the reductions aren't necessarily adding up linearly. But we estimate that roughly just over 1,000 megawatt hours can be reduced from the total energy demand of the building by incorporating all of the EEMs listed here. And it's really crucial that these strategies are adopted in the operations and design of the building if we're going to be able to achieve net zero energy. So with 70% of the roof area allocated to photovoltaics, the rooftop can accommodate an array size of approximately 975 kilowatts. So comparing a conservative generation potential of that size array, that's 1,700 megawatt hours, the building's anticipated energy demand is 3,800. So it's apparent that significant energy reduction efforts are necessary still to get that to that NZE goal. And if we take all the recommendations from the EEMs, and those are shown there in the blue bar, the energy demand, that would be lowered to 2,700, which is approximately 1,000 megawatt hours greater than the estimated rooftop generation potential, and that's shown in the orange bar. But basically this translates to 2/3 of the energy demand generated on site, but there is a need for about 590 kilowatts of additional PV elsewhere at the airport to achieve net zero energy for this project. We also did an initial SCAT study which showed compliance with the Federal Aviation Administration thresholds for glare, making NZ a plausible goal for this project. We're also recommending battery storage is considered in conjunction with the solar power panels. This would really align with LAWA's energy and resiliency goals. Incorporating the battery storage will help ensure the energy produced by the solar panels will be able to be used on site and provide added resiliency to the system. So let's get into waste. So an effective waste management design first evaluates and implements all feasible reduction efforts. And then next you look at reuse opportunities, and those are evaluated. And then finally an analysis of the most sustainable disposal methods is performed. So for this project, it will be designed to accommodate the separation of organics collection throughout the building for both pre and post-consumer organic waste, which will support the sustainability action plan that Tami referenced for the waste diversion goal of 100% of food waste from landfill. So we're also recommending that LAWA consider implementing a polluter pays principle, right, where the airlines and the vendors are charged waste hauling fees based on the amount of waste that they're sending to the landfill. So that would really encourage the airlines and the vendors to strictly adhere to the sustainability purchasing policy and help reduce their operating fees. And education and awareness are to impact and influence behavior change are really key to getting LAWA to the targets that are shown here. So now into biophilic design. So biophilic design is a deliberate attempt to translate an understanding of biophilia into the design of a built environment. And biophilic design has been found to enhance multiple facets of human well-being. So as an example, access to common natural spaces fosters social interaction and thus improves professional and personal relationships. And also natural lighting and ventilation result in improved performance and also very lower stress levels for all. So the estimated area of planting, we looked at that. We looked at the well building standard recommendations. And so for potted plants and planted beds, they like to see at least 1% of the building floor area. So that would be 1,400 square feet for this project. And they also recommend plant walls equal to 2% of the floor area. So that would be 28 square feet of green wall for Msc South. And then quickly on circadian lighting, right? The morning sun is blue spectrum light, which cues our bodies to release cortisol and wakes us up. And then conversely, evening light is red spectrum light, which causes our body to release melatonin, and that prepares us for sleep and restoration. So there's really significant health benefits to access to natural daylight and also to circadian adaptive lighting, which is lighting that emulates nature's cycles of light and dark, as well as changes in the color quality and the direction of the sun light waves that they exhibit throughout the course of the day. So getting into embodied carbon, the embodied carbon in a structure is defined as the carbon dioxide that's emitted in the extraction and the manufacturing and the transportation of the materials. And according to Architecture 2030, 11% of global CO2 emissions are associated with building materials and construction. And in commercial buildings, the majority of the total embodied carbon is primarily due to the building structure. So our initial analysis focused on the structure. So we used an open source tool that Buro Happold created, and it's called the Building and Habitats Objective Model. So we quantified the anticipated carbon emissions associated with the structure, and we used a baseline case, which is shown on the left of a steel moment frame, and compared that to the 3 different options that you see here that the team was considering. But essentially the solution we came to on the right was an optimized structure with a steel-braced frame. And as you can see here, there's a strong correlation between the structural cost and the embodied carbon. And we did this analysis to lower the overall steel tonnage and incorporate cement replacement. We ended up lowering the embodied carbon while also lowering the cost of the structure. And as we move through the design, we'll be focusing on embodied carbon reduction efforts on the steel and concrete, but we'll also be looking at facades and MEP systems and building finishes to understand the full embodied carbon picture. And getting into deconstruction, Richard touched on this earlier, but the lifespan for this project is roughly 25 years. So with this short-term lifespan, the primary opportunities that we see are around reusability or modularity and recoverability or disassembly. So the building is designed to be deployed as modules and reused as kits of parts for one or more different sites, and ideally they'd be located at LAX. But the modularity implies prefabrication, which will be completed in an assembly line in a factory. And there's lots of benefits to that. There's less construction material waste, it simplifies the site logistics, increases the speed of construction. And at the end of the building's life, reusing the modules results in significant material cost and carbon savings compared to new construction. And the building is also going to be designed to be deconstructed. So if at the end of the life, the modules themselves can't be reused. So designing for disassembly is really altering our design process from a traditional approach. So a couple examples, chemical connections will be eliminated as much as possible. So where there's structural connections, those will be bolted rather than welded. And architectural constructions will really greatly minimize the use of glue. And we'll be providing documentation that will be created to explain the ultimate disassembly procedure. And we'll be creating a deconstruction plan, and those notes will be incorporated into asphalt drawings, but also into the specifications. And next slide on circularity. So the transition to a circular economy is so important, and it entails decoupling economic activity from the consumption of finite resources and designing out waste out of this cycle. So in a circular economy, buildings are designed to be adapted, reconstructed, and deconstructed to the extent their life allows, components and materials to be salvaged for reuse and recycling. And really, in short, the goal with building circularity is to facilitate disassembly with minimal waste. So we used one-click LCA to do a circular analysis on the project. And with the high levels of sustainable source materials on the project, along with a really strong focus to the end-of-life options for the modules, Msc South is demonstrating 86% circularity. This really takes a dedicated team and innovative strategies throughout the design and construction process, and really includes, very detailed quantifying of material volumes, significant design team coordination, and the creation of the deconstruction plan. So then just a last final note, Msc South is such a great example of designing for our future, right? The impact of a regenerative approach, it has a reduced environmental impact, improved passenger experience, and greater resiliency for the airport during shocks and stressors. And once the project is complete, an exciting task will be the post-occupancy evaluation to demonstrate the net zero energy goals are being met. And that will really allow the team to understand how the building is performing. It will identify any measures to further optimize the performance and ensure the NZE targets. It will assess the design impact on the occupant satisfaction and productivity. And it will also engage occupants so that they're actively involved in improving their health and happiness. So this is a really high-performing building that touches the earth lightly and will really take great care of its occupants. So with that, I'm going to hand it over to Simon.
Thanks, Heidi. So I think as Tami, Richard, and Heidi really alluded to, the initiatives at LAWA in general, but then the specific strategies on this MSc South project really have the potential to create a tremendous amount of public value, not just financial value from utility savings, but lots of environmental and social benefits as well, in terms of avoided carbon, improved productivity, health and wellness. The problem is, a lot of these broader public impacts are hidden below the surface, and they're rarely acknowledged and let alone quantified. So that often makes it hard to justify their inclusion for certain owners, not necessarily LAWA because it's commitment to sustainability, but for others it can be harder. And an Autocase was used on this project to really better understand what those broader social, financial, and environmental impacts of each of the strategies were. So we entered in energy data for each of the energy efficiency measures. We looked at different PV capacities, the water efficiency strategies, as well as the material, the embodied carbon within the materials that Heidi was showing there near the end. Put that through Autocase to quantify and then value what those benefits really are. So if we just dive straight into the results here and take a look at the whole carbon story, what you're seeing here on this graph is the tons of carbon for a baseline building, code compliant baseline, against the improved design for the 100% SD submittal. And we've broken it down by major system as well. So we have embodied carbon in materials, energy efficiencies, on-site PV, water, and then the total carbon budget here. And so this is really showing which strategy is contributing most to the overall carbon budget and where you might be seeing the biggest reductions. And starting on the left, we can see that embodied carbon has been reduced by almost 2,000 tons by this design. And these are benefits that are accruing in year one. I think Heidi alluded to that, the contribution that materials are making to overall carbon. You're seeing these benefits right away. So this is good. Then if we look at the operational carbon from energy efficiency and on-site PV, you're saving around 15,000 tons from just those energy efficiencies, and then offsetting another 16,000 tons by implementing on-site PV. These are bigger than the materials, but they occur over the life of the project. So if we look at this in terms of a total carbon budget, the improved design has roughly around a quarter of the amount of lifetime carbon as that compliant baseline. And I think that's a really powerful message that the design team have been able to show here. So in total, that's saving roughly 32,500 tons of CO2, which is equivalent to around 40,000 acres of forests in a year. And if we put a social benefit to that, that's around $1.5 million that carbon is worth to us. So before I get into the details of what's on this slide, a lot of my role as an environmental economist is to convert things like air pollution into a monetary value and show what it's actually worth. So thinking about like understanding how reducing the pounds of PM 2.5 might influence hospital visits and the costs associated with that. And that's really what Autocase did on this project. We looked at the financial implication of energy and water savings, but also what that monetary value of reducing air pollution, reducing carbon and energy efficiencies of those as well. So what you're seeing here is the lifetime triple bottom line value of all of those various strategies. And keep in mind here, I didn't include the benefits to occupant health and productivity and a few other things here. So we're just looking at the energy efficiency measures and embodied carbon, as well as some of the water strategies. And the overall value ends up being over $11.5 million. That's the benefit of implementing these various strategies. The bulk of that is coming from energy savings and renewable energy, but over $1.8 million is in environmental benefits. And just breaking that down a little bit more clearly, that's 16% of the total value of these strategies is being derived from environmental benefits, which I think is important for us not to disregard here. So what's the point of putting a dollar value on these various triple bottom line impacts or these different strategies? And for me, I really allows owners to basically balance their financial responsibility against their carbon and their environmental sustainability goals. So they can choose the best strategies that give them the most or the biggest bang for the buck. And so what you can see here in this graph is you can start to rank and prioritize each of the different strategies side by side and compare them in more of an apples to apples way. So you can compare a material strategy versus a water strategy versus an energy strategy. And if we think of the implications of this on maybe on a project level, quantifying the different co-benefits of each investment, you're going from really a state that looks like this on the left, where you might not know what impacts are being created or how big they are, to one that looks more like the right-hand side. You can identify the various impacts, say how big they are, and then how much they're worth. So you can really justify and then compare between different much more easily and consistently. Then if we scale this idea up in terms of its implications for maybe cities or campuses or airports, this idea of having of being able to account and measure sustainability through this lens is really good for supporting planning, design, and reporting. So in terms of planning, we have fiscal constraints. Which projects should we go ahead with? Which projects are going to give us the biggest public value? You can compare between projects using this kind of metric that we've outlined. Within a design on a particular project, then you can then compare in investments, and that's what I was showing on a couple of slides. So you're able to identify maybe which investment is going to help us decarbonize the most cost-effective way. Then with reporting, you can really start to tell a better story to stakeholders and show a better value of what it is creating and measure meaningful metrics and really track that progress over time. I think as a final commentary here, I just wanted to point the modularity and that circularity, I think, is helping to future-proof LAWA. Modularity, I think it's giving some added business continuity. Like with everything that's in these past few months, we really don't know what the future might hold. There are lots of these known unknowns, but also these unknown unknowns. And by having a more flexible and adaptable infrastructure, I think it the airport well to be able to adapt to those changes that we might not know about. And then lastly here, I think the circularity shouldn't be seen as necessarily a cost add. It might actually prove to save costs in the future by being able to deconstruct and use those materials in a beneficial manner. You're actually reducing future capital costs. As well as, I think Tami mentioned, avoiding the landfill costs from construction materials, for example. So we shouldn't be thinking that sustainability isn't aligned with financial responsibility as well. I think there are the two can go hand in hand quite nicely. So with that, I'm going to end it here, and we should. I want to say a big thank you to Tami, to Richard, and Heidi for their great presentations here and excellent content. And yeah, we're happy to answer questions that you might have. But thank you all for listening, and thanks again.